Okay, so this is video for parabola part 2. Okay, so we already know that the equation for parabola are x square equal to 4py, or could also be y square equal to 4px. Okay, this is the parabola where the vertex is at origin. Okay, so next we also have equation for parabola where the x minus h square equal to 4py minus k, or could also be y minus k square equal to 4p x minus h. Okay, this one is for parabola where vertex is at hk. Okay, so equation of parabola in this kind of form is called as a standard form. Okay, it is called as a standard form. Okay, because from the first side we can already identify, okay, this is the equation for parabola where the x square is equal to 4py. Okay, so besides standard form, we also have equation of parabola in general form. Okay, in general form. Okay, so for equation of parabola in general form, it can be written as a x square plus bx plus cy plus d equal to 0, or could also be a y square plus by plus cx plus d equal to 0. Okay, as you can see, the general form for a parabola is actually looks like a quadratic equation. Okay, so now let's look at how can we change the general form of a parabola into a standard form. Okay, let's look at an example. Here we have y square plus 10x minus 12x plus 13 equal to 0. Okay, so in order to do that, firstly we observe which unknown have the power of 2. So in this equation we have y square, which is in the power of 2. And oh, sorry, here is a mistake. The 10x is actually 10y. Okay, now we separate the term of y, we put it on the left side. Meanwhile, the others, we put it on the right side. Okay, now from here, we start our process of completing the square. And we have y square plus 10y plus b over 2a, which is 10 over 2, 1 to the power of 2. And also put it on the right side of the equation. Okay, now we have to solve for the brackets. Okay, we have to expand y square plus 10y plus 5 square equal to 12x minus 13 plus 5 square. Okay, now we can factorize. We have y plus 5 square equal to 12x plus 12. And now we can factorize out the 12, and it will be 12x plus 1. Okay, so here is the standard form of our parabola equation. Okay, now let's look at an example. Example is to find the vertex, focus, and directrix of each of the following parabolas, and then sketch the graph. Okay, for question A, we have x squared minus 4x minus 4y minus 4 equal to 0. So in this equation, we have x which are in the power of 2. Okay, so the x which is in the power of 2. So we put it on the left side. So on the right side, it will be 4y plus 4. Then we proceed with the completing square. Okay, so the completing the square will be like that. And now we solve it, and it will be x minus 2 square equal to 4y plus 4 and plus 4. Then it will be x minus 2 square equal to 4y plus 8. And then we factorize the right side of the equation. That will give us x minus 2 square equal to 4y plus 2. Okay, now we have the standard form of the equation. Now, from the task, we need to find the vertex, focus, and directrix. So, the vertex we just take from the value of x and the value of y. So, we take x minus 2, it could make it equal to 0, and x equal to 2, y plus 2 equal to 0, then we have y equal to negative 2. So that we have value of h equal to 2 and k will be equal to negative 2. So that is our point for vertex, which is the hk to negative 2. Alright, next, after we have the vertex, what we need to find is the value of p. So the value of p will be related to the number outside the bracket of y, which is 4. Then we have 4p equal to 4. Then p will be equal to 4 over 4, p equal to 1. So since we have the value of p and the point of vertex, then we can identify the focus and equation of directrix. Okay, so this equation has a positive and the square is located with the x. So that means we have a quadratic equation, a quadratic like parabola, okay, positive quadratic like parabola, where the focus will be located above the vertex. So our focus will be 2, negative 2 plus 1 and equal to 2, negative 1. And the equation for directrix now will be below the position of vertex, below by 1 point, and we take from the value of k, negative 2, we minus with the value of p, so that negative 2 minus 1, and total equation of directrix will be negative 3, and don't forget to place the y in front of the equation. So that is equation of our directrix. So now we already have the vertex, focus, and directrix. What's left is to sketch the graph. Okay, so here will be the graph of the parabola. So firstly, we locate the position of vertex. So this will be the line of directrix, that is y equal to negative 3, and don't forget to label the y and x axis. Okay, so this I have another question. Y square minus 2y equal to 4x minus 9. So for this one, I want you to try it by yourself. So you can pause this video first. The task is still the same as the previous question. Is to find the vertex, focus, and directrix. And then don't forget to sketch the graph. Okay, so here is the sketch of the parabola. As you can see, the vertex is at 2, 1, focus at 3, 1. Meanwhile, the equation of directrix is at x equal to 1. And then don't forget to label the y and x axis. Okay, next is we want to proceed to next section. which is to identify, to equation of tangent to parabola at a particular point. So for this section, which is section 7.1.4, I want to use example 7.9, that is from page 183. Okay, so equation 1 us to show that y equal to 6x minus 9 is a tangent to parabola y equal to x square and find the point of contact. Okay, so from the equation of tangent, y equal to 6x minus 9 is the linear equation. So we know it is a straight line, then the parabola is y equal to x squared. Okay, so in order to determine whether the tangent is actually a tangent to the parabola, we take y equal to y and 6x minus 9 equal to x squared. Okay, then we bring all of the components into one side of the equation. X squared minus 6x plus 9 equal to 0. And now we have to try it with the equation of discriminant, that is b squared minus 4ac. So if calculated by the discriminant, then we have equal to value of 0. So now it is identified that the equation of the tangent is the tangent to the parabola. Okay, now let's try substitute. Negative 6 square minus 4, 9. And now we have 36 minus 36, and that is equal to 0. So from that we can make a conclusion that the y equal to 6x minus 9 is a tangent to the parabola of y equal to x squared. Okay, so now since we want to identify at which point is the point where the tangent touches the parabola, so we take the equation x squared minus 6x plus 9 equal to 0, and we factorize that and make sure we only get one value for x. So that will be the position of x where the tangent touches the parabola. Okay, so in order to find the value of y, the position for y, so we take y equal to 6x minus 9, the equation of tangent, and we substitute with the value of x. So now we have y equal to 9. So we have x, we have y. So then the point of contact will be at 3 and 9.